To use forward chaining, first of all, you need to make an assumption. This assumption is that since you are dividing n over 2, so we expect that we have n should be a power of 2, so that we don't get a other than integer. So the first step is that let n is equal to the power k. And k should start from 0 until infinity. Why should it start from 0? Because the first value of n is 1. And you know 1, if I want to make it a power of 2, I let k equal to 0, so 2 to the power 0 is equal to 1. Next, if you remember forward chaining, you need to find a few terms, and then from these terms you should guess the solution. So first one is we have T2, because T1 is given, is equal to 5T1 plus 3. Because if n is 2 and 2 divided by 2, you get 1. Since the value is expressed using the initial value T1, so we will leave it as it is. We will go to the next one of power of 2, which is 2 to the power 2, because this is 2 to the power 1. And this will be equal to 5t. Now when you divide 2 to the power 2 here over 2, you will get 2 plus 3. So that means you have to multiply 5 by the previous value. And the previous value is equal to, so what we will get, 5 multiplied by 5, we will get 5 squared T1 plus 5 times 3 plus 3 from the previous step. Now for the next value, 2 to the power 3, you need to multiply 5, because this is what does it say. You need to multiply 5 by the previous value, and then you add 3. This is, you can write it explicitly by saying 5 square, this should be 5 t2 to the power 2 plus 3. And t2 to the power 2 is the previous step, so it will be equal to 5 raised to power 3 t1 plus 5 square multiplied by 3, 5 times 3 and plus 3. Maybe I should go for one more. 2 to the power 4. It says that it should be 5 multiplied by the previous step. And this is the previous step. Just multiply it by 5. You will get 5 raised to power 4 t1 plus 5 raised to power 3 multiplied by 3. 5 square multiplied by 3. 5 multiplied by 3 and then plus 3. Now we have enough values of Tn to guess the solution. Now we are not going to guess the solution in terms of n. We will guess the solution in terms of k, 2 to the power k. Now, if I have 2 to the power k, by just looking at the last equation we have obtained, we can find a closed or a guess solution for 2 to the power k. So 2 to the power 4, we have 5 to the power 4, but here we have 5 to the power 3 in each term. So here we can include also 5 raised to power 0 to complete the set of 5 raised to power something. And then we guess that here we will have 5 raised to power k t1 plus, now we have a summation, but 3 is also common to every term. So it will be 3 summation 5. I will use j for the power, and then I will look at the summation from right to left. So here we have 5 raised to power 0, so k will start from 0, or j will start from 0, and here we will have 5 raised to power j. Now what is the last value for j? If you looked at on this value, which is equal to 4, the last power is less by 1. So if I have power k for 2 to the power k, so the last value here will be k minus 1. Notice that the summation is geometric sequence and it already starts from 0. So there is no need to modify the indices. So we can find the answer or a closed form for this equation it will be 5 raised to power k. Now t1 is already equal to 1, so multiplied by 1, plus 3 times 5 minus 1, 5 raised to power k, not n, minus 1. So this equation is given in terms of k, not in terms of n. So we will simplify this equation, and after the simplification we will get 5k plus 3 over 4, 5k minus 3 over 4, and this is equal to 7 over 4, 5 raised to power k minus 3 over 4. I can say here that 2 to the power k is equal to this. But still the answer is in terms of k. We need to find it in terms of n. From the beginning, since n was equal 2 to the power k, now I need to find the relationship between n and k. So take log 2 both sides. Why I'm using log 2? Because we have power of 2. So logically we take log of 2, and here what we will get? We will get log 2n is equal to k log 2, and you know that log 2 and 2 is equal to 1. So therefore k is equal to log 2n. Substitute. What we will get? We already know that 2 to the power k is n, so we have tn. When I say substitute, it means substitute here, which is equal to 7 over 4, 5 raised to power log 2n minus 4 over 3. And this is the answer in terms of n, but you remember in log, if log is in the power, then we can swap n with 5. So we can swap between these two. Why? Because if someone looks at this recurrence relation, might think that this is exponential, and if we ask what is the running time for this algorithm, by mistake might say is exponential. However, this is not exponential, this is polynomial. And if you rewrite it, we can say that tn is equal to 7 over 4 times n raised to power log 5 minus 4 over 3. And log 5 is in fact a constant. By using the calculator, it is found that tn is equal to 7 over 4 n raised to power 2.3 something minus 4 over 3. So if I ask you what is the running time for this algorithm, is theta n raised to power 2.3.